All right, today's notes are section 5-4, the triangle midsegment theorem. And so our objective is to prove and use properties of the triangle midsegments. So let's first start off with the definition of the midsegment of a triangle. So it's a segment that joins the midpoints of two sides of the triangle. So it's a segment that joins the midpoints of two sides of a triangle. So if I have a triangle and I were to take the midpoints of two sides and draw a line connecting those two sides, that would be a midsegment. So how many midsegments do you think exist in one triangle? Well, 3. And they form a midsegment triangle. So if we have our triangle and we take the midsegment of each of the sides, or midpoint of each of the sides, and connect them with segments, we end up with a midsegment triangle. So there are some properties that we are going to discover from the midsegment, so let's look at those. The first thing we need to talk about is the distance formula that we're about to use over here. So remember that the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So A says find and graph point K, the midpoint of HG, and then find and graph point L, the midpoint of HJ, and then draw in KL. So last couple classes we used the formula for midpoint, but if we already have a graph, there's a little bit of a shortcut. So if I can find the slope going from H to G, so going up 1, 2, 3, 4, 5, 6, 7, 8, and over 1, 2, if I cut that in half, if I divide both of those pieces by 2, I get 4 over 1. From G, I go up 4 and over 1. And this would be the midpoint of this line segment from G to H. So we'll call this point K, and it looks like point K is at -6, 2. So we'll do the same thing for HJ. So from J going to H, I have to go up 1, 2, 3, 4, and then to the left 1, 2, 3, 4, 5, 6. So if I divide both of those by 2, cut them in half, I get 2 over -3. So up 2 and over to the left 3. So this should be point L. And that looks like it's at -2, 4. So now we're going to connect these two lines, and that will be my midsegment of this triangle, one of them. So it says find KL, and that means find the distance, the length of KL. So we go and use our distance formula, and we say it's x2 minus x1 squared plus y2 minus y1 squared. So if I simplify that, I get the square root of 20, and this says write it in simplified radical form. If you don't know how to do that, we're going to talk about it a little bit in class. So you can either type this in your calculator on your phone or whatever you have and get a decimal, or we'll talk about how to get this reduced radical form, which would be 2/5, or 2 in the square root of 5, I'm sorry, in class, next class period. So it says we need to do the same thing for GJ. So let's use our distance formula again, and we're doing GJ. It looks like G is at -7, -2, and J is at 1, 2. So x2 minus x1 squared plus y2 minus y1 squared. So if I reduce this, I get the square root of 80, which reduces to be 4 square root of 5, or you probably got some sort of decimal in your calculator. But what do you notice about the length of KL and the length of GH? Well, I'm sorry, GJ. GJ is double the length of KL. So that means KL is half the length of GJ. Just restating the same thing. So that means that my mid-segment is half the length of GJ. So if KL had been 10, GJ would have been 20. Well, what do we notice about the slopes of KL and GJ? So let's look at the slope of KL. The slope of KL is rising 2 and then running 1, 2, 3, 4. So 2 over 4, which is a half. The slope of GJ is up 1, 2, 3, 4 and over 1, 2, 3, 4, 5, 6, 7, 8. 4 over 8, which reduces to a half. So what do we notice about their slopes? The slopes are the same. So what does that mean about their lines? That means the mid-segment is parallel to another side. So KL is parallel to GJ because they have the same slope. So let's look at the mid-segment theorem. We kind of just proved the mid-segment theorem. It says the mid-segment of a triangle is parallel to a side of the triangle. So we said KL was parallel to GJ, and its length is half the length of that side, and that's what we came up with up here. KL was half the length of GJ. Alright, so now let's actually use this theorem a little bit. So it says that given that ST, this whole length, is 7.4, it says find each measure. Well, if this is a line, and I'm looking for UW, so I'm looking for this length right here, I know that this whole thing is 7.4, and UW is a mid-segment. So this, since it's parallel to ST, UW should be half of 7.4. So half of 7.4 should give you 3.7. So the length of UW should be 3.7. The next thing says find the measure of angle SVU. So SVU, I'm looking for this measure right here. So I know that this line is parallel to this line, and this segment right here that goes through my two parallel lines could be called a transversal. So I'm going to turn my paper where it looks like I have parallel lines going sideways. If this is 41 degrees, that means this angle SVU also has to be 41 degrees because those are alternate interior angles. My parallel lines, they're inside them and they're on opposite sides of the transversal. So that means this angle has to be 41 degrees. And the last thing, RT. This whole length down here, its mid-segment is UV. So if UV is 5.2, that means RT has to be double that because I know that the mid-segment is half of the other side. So 5.2 times 2 would give me RT being 10.4. All right, let's look at the next one. It says find X and Y. So let's start off with X. I know that this length right here is half of this length down here because this is the mid segment and this is the side across from it. So I know that 2x minus 3 is equal to half of 5x minus 12. So let's solve for x. I know first I need to distribute. And then I need to combine my like terms. So I'm going to subtract 5 halves from 2, which gives me a half x. And I'm going to add 3 to negative 6. Sorry, it gives me a negative half x. I'm sorry. And I'm going to add 3 to negative 6, which gives me negative 3. And then I'm going to divide by a negative half to get x equals a positive 6. So I should go back and check my answer. So if I plugged in 6, 2 times 6 is 12, and 12 minus 3 is 9. So this length right here is 9. And then 5 times 6 is 30, minus 12 gives me 18. So is 9 half of 18? Yeah, so x equals 6 is right. So the next thing we need to do is find the value of y. So we're looking at angles. So I know that I'm going to have to find parallel lines. Well, if this is the midsegment, that means this line is parallel to this line. And then this right here would be a transversal. So I'm going to turn my paper so I can look at my parallel lines straight up. I'm looking at this angle and this angle. What kind of angles are those? Well, they're same side interior, and I know that same side interior angles add up to be 180. So 117 plus y should equal 180. So if I subtract 117, I end up with y equals 63 degrees.